It's 1:30. Let's start. My name is Anne Wendel. I work for the VDMA Robotics and Automation Association. And it's my pleasure to be here and to moderate an exciting panel digging into embedded vision. We, VDMA, have been organizing panel discussions here at Embedded World about embedded vision quite a few times now. And it's exciting to see how the topic has evolved over the years. So if you walk the halls here at Embedded World, you can see that embedded vision, you can see so many application examples based on embedded vision pushed by AI. So I can say embedded vision is an indispensable tool of Embedded World, and therefore let's discuss embedded vision. So let's dig today into the topic how new hardware designs and physical AI are pushing boundaries. My plan is to start with application examples, then talk about hardware innovation. Of course, we will also cover software. We will talk about the system design, and we will talk about the future. So what challenges are there? I would like to invite you also to raise questions. So whenever you think, that's something I would like to know, please raise your hand. Konstantin, sitting behind, will come with a microphone to you and will address your question. Okay, so that's from my side. I would now like to warmly welcome my panelists. And you know each other better than I do, so I would say, please introduce yourself and explain briefly what your company does with regard to embedded vision. So are you more on the hardware side or on the software side? And also, please start with an exciting application example your company has been working on lately in the area of embedded vision. So, shall we start with you, John?
Sure, yeah, happy to. Please. And thank you for the opportunity. And thank you for spending time with us for an hour this afternoon. My name is John Healy, and I run the Industrial and Robotics Division at Intel. So maybe Intel doesn't need an intro, but I'll tell you a bit about what we're doing. And particularly in my area, we consider our mission or our purpose to create technologies that enable our partners to bring solutions to market, to solve some of the biggest challenges they have in their industries, but also to create new opportunities for them. So particularly in my area, I look after manufacturing, the energy grid and the modernization of how energy is distributed and provided, and increasingly a big focus on the growth of robotics. So if you think about embedded vision in those markets, it has value in all three of them. In fact, in a lot of ways, embedded vision found its home in industrial markets, in the manufacturing, providing new insight to the manufacturing processes that have allowed a lot of end customer users to create real value in how they manufacture, identifying defects and identifying process optimization opportunities because of the insight gained through the visual inspection of their product. But now, as Anne asked, what's exciting that you see today, if I move it into the world of robotics and the growth of physical AI, what we're seeing increasingly is that embedded vision is one part, but a very significant part, of the eyes of the robot that allow it to see and do things that it could never do before in response to the environment it's operating under. So we see really exciting applications of robots entering into environments that are unstructured, for which they have no prior knowledge, and they adapt to what they find as they navigate that environment. And that adds real value to the deployment, to the companies or the customers deploying them in what they're able to achieve as a result of it. That's super exciting, but it has as its core embedded vision as an underlying capability. So super looking forward to the conversation today as we develop how, as an ecosystem or as an industry, are we taking advantage of these technologies and where are they going?
Thank you, John. So embedded vision enabling devices to see and to understand the world. That's embedded vision. Perfect definition. Frederik.
Thank you. My name is Frederik Schönebeck. I'm from FRAMOS, which probably, unlike Intel, needs some explanations. FRAMOS is a Munich-based camera module company. So I think we are very much operating in similar domains that John has described. It's super exciting to see what kind of devices today require eyes to perceive the world, and whenever a device needs eyes, we are trying to get those customers the right eyes that they need to be successful in their application. Camera modules means the right image sensor technology, the right optics, the right tuning, the right interface. The landscape we are seeing is very diverse, lots of different architectures, and we always try to get our customers the right camera modules for their specific application. Lately, I think we've seen a huge pickup when it comes to autonomous devices, robots of any sort, in all kinds of different applications. And, well, deploying robotic systems poses lots of challenges for the suppliers. And, yeah, I'm curious to see where this discussion will go.
Mm-hmm. And Frederik, if I may add, you're also involved in many drone applications lately. Yeah.
So, yes, drones being, for us, I think drones is a specific instance of a robotic system that is even more battery powered, even more lightweight. So when it comes to size optimization and cost optimization, I think it's sort of at the extreme level. And yes, we also saw quite a pickup of drones in the last couple of years.
Okay.
I use this microphone. So good afternoon also from my side. My name is Olaf Munkelt. I am co-founder and managing director of MVTec. This is the title I have on my business cards, which for almost 30 years. And we do software for machine vision or for embedded vision. So we are the guys who actually process this huge amount of data which are passed to us from the sensor, from the camera, and hopefully do something like robot guidance or support that, or do something like following objects, tracking objects, or sorting particles, and all these kind of stuff. And maybe a little more words from the history, so to speak. We started this embedded vision topic like more than 20 years ago already. By that time, we had a huge range of different CPUs and different architecture. We had DSP architectures, for example. Nowadays, this is way easier. The architectures, to a certain degree, have standardized. So it's more easier now to bring even challenging applications on an embedded device.
Mm-hmm. Thank you, Olaf. Henning.
Yeah, my name is Henning Tiarks. I'm the Chief Product Officer of Allied Vision. I think Allied Vision needs some explanation as well, providing cameras, camera modules, frame grabbers, embedded vision, processing technology, also for a very long period of time. We are in that area mainly working with, in that embedded vision area, mainly working with customers out of the non-factory part at the moment, also especially things where machines or vehicles need to move in the air, on the ground, wherever. So there could be in agriculture, could also be in other applications. Well, what we do see is that things go back to the factory and into the machines nowadays, where the embedded technology is now really going back to the heart of manufacturing.
Thank you for this introduction. So we have it all. We have camera module providers, software, and also Intel, a complete also processing boards and AI accelerators. So thank you. Yeah, let's dig into hardware innovation. So embedded vision on the rise. So the latest years. What hardware breakthroughs have you seen that is really pushing embedded vision? So Olaf, you already mentioned new architectures, GPUs, NPUs. So let's dig into that. So what was really like a major breakthrough from your point of view?
Yeah, I said that today it's much easier to work with the current CPUs, NPUs, because the number is a little, and they are easier to handle. And I think embedded vision for many years lacked the usability. There was a lack of usability, and this is getting better. We see more tool chains, more easier to use tool chains, and the more easier it is, the more people will apply it, the more people will play around it, and will get a good feeling about it. So hardware is, of course, a major issue, because when we can't compute something, we cannot perform any application. So what it means on the other side is that there's such a strong demand for processing a huge amount of data, especially when it comes to AI-based application. So we are the ones who really wish and appreciate the more power, the better, the less power consumption, the better, the smaller the footprint, the better, and then we can bring more exciting application to the hardware.
Frederik.
I would like to respond to the statement of smaller footprints. I think when it comes to breakthroughs or innovations, I would rather describe it as an evolution of lower energy consumption, smaller form factors, and I think it's really those two things that drive embedded vision. Because if there's one thing that we are observing, is that in embedded vision things need to be compact, need to be cost optimized, and there I think you don't want to have your data center connected to your robot. It needs to be on the edge, and we definitely see how the top performance and also the TOPS per watt performance is really increasing every year. At the same time, when we look at the camera front end, pixel performance is getting better and better, allowing for smaller pixels, which also saves cost, saves power consumption. Optical manufacturing is also sort of following and is able to produce high-performance optical lenses in a much more cost-efficient way than 10, 15 years ago, which also contributes significantly to driving embedded vision. So I think it's throughout the complete stack, where in each part the respective technology is advancing year by year, and at the end you get smaller and smaller, while at the same time more powerful systems, and only that allows to really deploy embedded vision at large scale.
Yeah, and I'll just pick up on that, Anne, because it's kind of fascinating when we talk about hardware evolution and the differing perspectives of all of the change that's occurring at the same time, which is making it even more compelling for the kinds of applications that will come as a result. And if I think of the foundation underneath the embedded vision and at the path it takes going forward, particularly with the application of AI, one of the areas we've seen significant advancement is in what I'll describe as heterogeneity, or heterogeneous architectures that underpin this processing or compute support for the application. So CPU with its classic, capability to support things like real time and application centricity or control, say in a robot, but then add to that the integrated GPU architectures that provide for high levels of parallelism, which is really critically important for AI models to run, and then increase to that the integration of NPUs. So all three subsystems, the NPU focused on very high efficiency AI performance, so then you can target the application to the best processing node underneath or processing subsystem to support it. Now you say, well, yes, that's three different processing areas. Where's the breakthrough? That's heterogeneity in a single device. So as we looked at the world, one of the products we've created, the Intel Core Ultra 3 series, is an integrated three subsystem in a single SoC. And so that in a lot of ways enables application categories to be deployed that are most targeted toward the deployment of applications at the edge, allowing for that separation of cloud and edge to provide for the performance required in the footprint that's necessary at the power levels that are appropriate and practical. And so as an underpinning, that's a breakthrough that we're just beginning a journey that's going to continue to enable us to deliver more and more performance in the appropriate size at the edge, which will unleash so many more applications as a result.
Okay. Thank you. So I guess you four gentlemen will agree that embedded vision is not only driven by software efficiency, but it's also driven by breakthroughs in hardware. We digged into that, so thank you. Any questions from the audience regarding hardware before we move on? I don't see any further questions, so let's move on towards software, or hardware versus software. So we already covered that hardware plays an important role today. So cameras are not becoming a minor matter, we have covered that. However, let's cover the more powerful software computing power a little bit more, and also what role does AI play?
Maybe I start on this. So I think, John, you already mentioned an important point. Bringing together different CPUs, NPUs, so different SoCs, so to speak, and having a stack on top of it which allows a transparent access on this data is crucial for building especially AI applications. So for us as a software vendor, it is important to have a layer where we can simply trust on and where we can get this, the same function just accelerates because there is an NPU available. And that's simply great. And this is what we need when it comes to problems like anomaly detection, semantic segmentation, object classification, and you name it. So the standard AI applications, which already need a lot of computational power, the smaller the objects are you need to detect, and the larger the image is, the more computational power you must have in the back, so to speak. So we actually are the ones who appreciate every single speed up because that gets us an opportunity to tackle applications which we have not tackled before.
And you are right. At the end, there is no value for the customer if there is a great piece of hardware, but you can't use it. There is no optimization, there is no access. So I think in terms of what matters to the community, then it's all about enabling the community with the right frameworks, starting from low-level drivers so that everything can be purely optimized. In fact, actually, that's a tendency we see that our customers would like to have as much of a low-level access as possible to ensure that they can optimize it, especially once they want to deploy across larger volumes and they want to remain in full control. And that's also why we as a company, for instance, we have decided to open source all our drivers to enable the customers and not lock them into a sort of a black box type environment.
That's interesting. So I have to ask you, so what benefits do your customer get from these open source drivers? Is this like a magnitude, or is it like, I've done this because I'm a technical guy and I know exactly how to tune it?
I think they're mostly looking at this from a risk perspective. When they start their journey, they want to be able to still navigate later on in whatever direction they need to navigate, because typically in these emerging markets you don't really know where your product will end up and what specific features you may need. So you want to keep the doors open, and so we clearly see that they are favoring modular open systems, and of course it's not that they want to reinvent the wheel, so they are seeking for a sort of reference implementation, but once they understand really what their requirements are, then they want to be able to really optimize for those requirements, and we see that they really appreciate this open source approach.
And I have to pick up on that because it's a super important point, by the way, Olaf, that you asked, and Frederik, that you added to, because when you consider the opportunity that we talk about, when you mentioned specifically AI in the context of software, we have a saying inside Intel that without the software, we build wonderful pieces of sand. The software brings it to life. The software exposes the value of the innovation. What happens as a consequence of that, though, is really important because the applications we serve and particularly for embedded vision, we'll use that example because it's so important. They're so diverse, the markets are so fragmented, that a way of unifying capability is what we talked about in terms of open source. Openness generally is an enabler of wide, diverse access to technology that unleashes the innovation to occur across the industries. So we're very committed to the way we support the exposure of the assets we've invested in the hardware through the software contributions we make across open source for that very reason. Frameworks that are standardized, components that are modularized, and access through open source communities stimulates the innovation that then allows for the solutions to be developed that serve and support a diverse multitude of applications across the industries. And that's where the real magic happens. So it's critically important as a part of enabling any new advent. And I think AI is another evolution in a continuum that we're all living through that started with basic computing and is taking us to who knows where, but continued application capabilities as we provide for more analytics, derive more insight, and create more value from the data that's captured as each of our devices or each of our processes are running. So really important multiplier underneath all of this that enables it is the path towards openness, and open source as part of it.
Mm-hmm. Thank you. So one last question towards hardware versus software, or I mean it's all about embedded vision. We heard about AI, we heard about processing power of ever bigger, more capable camera systems. So how to balance performance, power consumption, and ever smaller footprint, and of course cost in embedded vision applications. So anyone would like to dig into that?
Yeah, maybe I can also elaborate a little bit on that. What we do see that this is, besides that technology needs to be very open to the customer, we definitely see that this is something you find out also in a project with the customer, where you start to pick and choose the hardware pieces by understanding what the customer wants to do with that, and design special boards, special cameras, or use bits and pieces that you have on stock to combine it to very special hardware that can be used by the customer. So it's also a question of the system architecture, understanding that, and then deriving the right hardware solution out of that.
I mean, we are facing this question every day together with our customers and reflecting on it. There is no general recipe. The advice I would always give is look at the tasks that you need to accomplish and pick the most critical ones and start identifying your requirements around these. And then, now from a camera perspective, there is a few sort of simple scaling mechanisms. Try to pick the smallest pixel that still does the job, because smaller pixel means smaller sensor, lower power consumption, lower cost. Also, with a smaller sensor, you can start minimizing your lens design as well. From a compute perspective, try to reduce the data rate. So don't over-engineer your resolution, because every pixel you sort of get, every photon you collect, you need to process. So also there, just try to get away with a bare minimum, and sort of to understand what your bare minimum is. The advice is always focus on what are the main tasks you need to accomplish, and then you can always add to that later.
Yeah, maybe the one addition I'll make, Anne, is when we work with our customers on building solutions, and they're trying to balance, as you described, and oftentimes it's really not a balance at all, it's an optimization conversation. And so it's critically important to consider the application at a system level. All of the componentry, all of the aspects of what you're trying to achieve at a system, and then think through what are the critical indicators that I must have. The power budget, thermal limitation, throughput, quality of outcome that I require, level of fidelity that I need for the application, and then work through the optimization cyclically at a system level, which is by definition a combination of hardware and software, working in a virtuous spiral so that you can create the best outcome. And then you need, underneath that, the flexibility or agility of the assets you're building with to allow you to flex depending on the need of the outcome that you're trying to deliver. But it is fundamentally a system level challenge, not a singular metric challenge. And that's what we find all the time.
Yeah, so work on the system level together with your customers, and depending on the application, that is what comes out. Thank you. Three of the gentlemen here, they come from the traditional machine vision field. I mean, yeah, vision, computer vision is nothing new. You have a lot of expertise, like 30 years in the industrial automation area, so to speak, or even more. So, do you see many customers migrating from classical machine vision, PC-based machine vision, towards AI-based approaches, embedded vision? Do you see that?
I think I said it in the introduction. It's not yet that everybody is moving quickly over. What you could see is that solutions you build in the embedded vision or based on embedded vision technology, you can transfer them into machines, and that helps these machine builders to even benefit from the advantages of the technology from embedded vision. So typically it's price, but it's also size, and it's often things like power consumption, everything people are looking for, but they don't make the jump. And the examples that we see, they are already customers have rebuilt their system architectures because they want to use AI, and then in that occasion they need to go through the whole system architecture and change it, and then it's open for embedded vision as well.
Yeah, I can totally agree to your comment. Maybe one more point. In these 3 days, we already saw existing customers, which usually go to other shows for the machine vision industry. They walk this show and walk around and see, is there an option for me here to, cut down cost on my CPU? Of course, they also want to cut down costs on software. Yeah, this is the usual way. Yeah. So this is why it is good that we are here and we can talk to them and we can bring forward our arguments. So it's actually happening. People are looking for more cost-effective, more smaller footprint for different options. And I think these are the two lines. One line is people really have an embedded vision applications. They don't think about bringing a big PC workstation somewhere. And the other ones, they do have a big PC workstation, which they use for different purposes, and they sometimes have an option to reduce cost if they go for an embedded hardware system.
I would say for us, for FRAMOS, it's the vast majority of customers who I would describe as embedded vision customers. I mean, embedded vision is there's no clear definition, but when we sort of go into a context of not a big box, bulky compute box, but rather an edge device, and at the same time the camera module being sort of small and fully optimized, this is our bread and butter business, and we really see how this is growing year by year.
Mm-hmm. So a lot of new customers, new ideas, computer vision embedded in devices. Yeah, definitely. Okay, any questions? Here, I see one question. Mr. Hesse. Konstantin, may I ask you?
I assume you have a roadmap in your division. How does this roadmap support the ever-increasing specialization of applications?
Good question.
Great question. And so I mentioned earlier the heterogeneity of the roadmap or of a product, having compute complexes within the single product that can be tuned towards the application that they're serving. That's the path to enabling future product capabilities or application capabilities out over time. So the roadmap continues to evolve to provide for best, deterministic performance, general purpose compute, in addition to integrated accelerators with a GPU and an NPU for the AI workloads, both today's models or the models that are evolving for the future. And so it actually ties to the last question about how do you optimize for the need, or how do you balance the need. It's having the flexibility across each of those different underlying compute capabilities to partition or to architect where you need or want each part of that application to evolve or to be deployed. That's the first piece, the flexibility to allow you to architect where you want any one of those two components or elements of your application to be processed, so that you optimize for the footprint. The second ties to the conversation and what Frederik was just saying, in the ability then to do more and more locally at the edge because of the performance and capability of that platform. So you need scale to do that, from lower power, lower performance, to mid-range power, higher performance, and upward, all the way through to an edge-based server, if that's where you really want to do more involved model training, model fine-tuning, and then model deployment. Because what's clear is that, A, the continuum isn't going to slow down anytime soon. Secondly, we need the flexibility to allow us to do continuous retraining of models in deployment, because the days of building a deterministic system that says it's configured to do one thing today and I'll leave it run forever are gone. Now the value is in being able to retrain and re-optimize and retune as the application is in deployment. So that's what the roadmap's designed to do, is to create across those vectors the flexibility to allow that to occur. Great question.
Mm-hmm. Olaf,
there's one, because you just mentioned this retraining stuff. Very typical for if you build an AI application, so you're super happy once you have built it. And then after a certain while you recognize, it doesn't really do what I want them to do. So you have to kind of readjust that. Very often it means that you have to retrain part of it or the entire thing. And depending on what the scale of the problem is, you need more computational power. This is a gap which still exists. I'm not saying this has to be bridged. I'm saying there has to be an architectural way to address that, so that you have somewhere in the back the computational power to retrain and then to quickly download on an edge device. So the edge device itself has very limited capabilities to get retrained on the fly. If we talk about an AI application which you maintain for a longer period of time, I think you have to take this into account as well. So for us as a software provider, we simply appreciate if we can use, say, similar hardware and very similar software stacks to make this available. Mm-hmm.
I would actually like to expand on that. What you said, that architectures are sort of diversifying, and you have different processing performances, 1 TOP, 10 TOPs, 100 TOPs, also different power efficiencies, software stacks evolving, retraining. What I think is becoming a thing to actually control all of that is simulation workflows. That when things are changing, when hardware is changing, when you learn something in the application, so when you need to retrain, you don't retrain in the physical world, but you have a digital twin of your system, a digital twin of the camera, a digital twin of your complete software stack, a digital twin of your data, synthetic data, and with that you can advance in your application. You can retrain your application much more quickly compared to always doing this in the real world in a physical sort of physical implementation. That's something we see. It's something we are trying to support. I think we are still early, but we see customers using this, and they are evolving much more quickly than if they sort of just did this the classical way in the physical world.
Mm-hmm. Physical world, that's a good point. So let's dig into physical AI. So whenever you browse here or wherever, you see a lot of course, AI-driven applications, but also physical AI is pushing embedded vision. So, would any one of you would like to give a definition of what physical AI is, or should I try it? So, from my understanding, Olaf, please.
This is one of the phrases I really like because in Germany we had Industry 4.0.
Oh yes.
Yeah, this is also kind of a fuzzy term. Everybody knows somehow what it is, but if you ask can you give me a definition, then it gets a little tough. So physical AI, I think if we look forward for new systems, new hardware systems, then these systems they only exist because they have AI inbuilt. Like a humanoid robot, for example. If you look at existing systems like machines, which do a certain inspection or so, then adding on AI capabilities would make them to a physical AI system. So this would be my very rough definition.
For me, physical AI is very much connected with sort of vision language models, vision language action models, sorry. So everybody of you is familiar with language models, the big ChatGPTs, Copilot and the like. There's vision models, and I think there's vision language models, but physical AI means something happens in the real world. There's an action triggered, and this action needs to be controlled, and it needs to be controlled by the vision and the language, the interaction that the machine has with the real world, with the physical world. And there is this new branch of AI models, vision language action models, VLAs, and I think this will drive the physical AI substantially. And this is sort of my personal take on how I would try to describe physical AI.
Definitely. So to understand and to interact with the real world, you of course need embedded vision. So would you agree that physical AI is pushing embedded vision? Yeah? So what exciting new applications do you see when talking or thinking about physical AI? Olaf mentioned humanoid robotics.
Robotics across different industries, logistics, for instance, being one where robots of all kinds are already deployed today. I think an interesting one is also in medical and healthcare. Any sort of robot-assisted surgeries is a classical example where, based on vision input, based on language input, there's a robot assisting the surgery. So it's always some sort of robots, but the application of the robotic system, this is really universal. It's across all industries.
Good, thank you. Further questions regarding AI in practice here from the audience? There is one, please, Konstantin.
Yeah, thank you. I guess this question can be expected from a younger person like me, but what would you recommend being a good literature to get into your field of work, to get it to know better?
So how to start with embedded vision?
Basically, yes, but also the academics of it, specifically the AI.
I didn't understand it, pardon. Could you repeat, please?
Okay, maybe I said the question wrong. Is there any literature on embedded vision? Yes, yes.
Literature on embedded vision. So if someone wants to start with embedded vision, for example, is there some recommendation?
I would say, so from a camera module perspective, what many of our customers do, typically they decide on a compute platform that is of interest, of whatever vendor. And then typically all these vendors have a reference implementation of some sort of camera, and they show you a reference implementation of a typical AI framework, and then they start building from there. So it's a sort of a development kit type of approach where you need to get a package of the right hardware, and there's typical good documentation in whatever community. And it depends a bit on which compute platform you select, but it's always the same approach, I would say. Is that a helpful answer?
It is. It is. Thank you very much.
The only thing I would add to that, in addition, I think that's a great suggestion. Also worth looking at vendors' web presence. I mean, I'll obviously push intel.com. You'll find some solution briefs and things there. But to really learn about how the industry or the communities at large are starting to embrace some of these possibilities, it's well worth spending time on the ROS community, ROS, the robot operating system. It's worth going there because you'll see a lot of the kind of capabilities that are being developed by a diverse range in the community, and they publish good content there that you can just learn from, tutorials, ways of using the assets, all software, but it'll point you in a lot of the right directions. Good question.
Okay. And of course, here at Embedded World, you can go to Hall 2. There's Embedded Vision area where you can find a lot of companies active in Embedded Vision, and you can just grab one of them and ask them questions. Okay, thank you. So, to conclude on AI in practice on this topic, would you agree that AI-driven embedded vision systems really have an impact on robotics and automation, and also on looking into future applications?
Definitely.
Definitely.
There's no doubt about it. Since we do have AI, we do see way more applications which formerly could not be addressed using, say, rule-based
and
approaches.
AI in combination with vision.
And
definitely.
AI in combination with vision is a very good fit. And apparently, as I walked over from Hall 2 to Hall 3, there's literally no stand without a vision, an embedded vision system somewhere. Even it's a demo board, but there's a camera somewhere, and they track people. They actually see where your skeleton is, where I'm having problems. Do the same thing if I look at myself. So there are so many different and funny applications. So embedded vision is everywhere, even it's not in the embedded vision section.
That's true.
And I think what makes the difference is that only with AI you're able to address use cases that are uncontrolled, unconstrained. Typically with classical computer vision, everything needed to be deterministic. You needed to control your environment. This was sort of locked to the factory floor. To really deploy physical AI-based systems in volume, you need to be able to hit the world, to manage the unknown and the uncontrollable world. And I think only with AI-based approaches you're able to make the system behave that it needs to behave to do the job in that open world. So to me, this AI is really the game changer there.
AI in combination with vision, I guess. Yeah, okay. Thank you. So looking at... Henning, of course.
One thing to add, I guess you can have real-world proof if you go to the, let's say, established robotic manufacturers and look what is happening there. So they're doing a lot of alliances at the moment. They are pushing camera vendors to make models for the metaverse, things like that. So they are really, either they are already doing that, or they now heard in Germany, den Schuss gehört, they really had the signal to start it all over.
Definitely. What other sectors, apart from the robotics industry, what other sectors are leading in adopting new embedded vision technologies? What do you see?
Yeah, robotics is of course very funny, because if you see the YouTube videos about humanoids, sometimes it's really very funny. So, but what we see are applications in the agriculture sector, for example. where it's now way more easier to determine whether plants grow in the right direction or in the wrong direction. So, embedded vision in these applications really adds a lot of value because you can actually reduce the amount of pesticide to actually help the plant grow. In that field, there are numerous applications. So agriculture, I would say, is a really big thing.
Yeah, we also see some really interesting applications in retail.
Retail.
Think about automated self-checkout. Loss prevention is a nice euphemism for stopping theft. But very good applications there in managing interactivity with the customer. So you have a point of sale that also doubles as a suggestive, promoter of other product, and vision provides for the insight it can see and propose. So a lot of applications there. Also in building management or crowd management within a building with volumetric analysis and managing profiles or traffic densities of the people as they move around. We've seen that in city applications, in airport applications, even in hotels, to manage for the flow of the people around the building, all enabled by computer vision.
I think we talked about also in the beginning that we definitely see that in this, I would call it drone, but everything, vehicles that move, fly or swim autonomously, even communicate with other vehicles in order to move in a certain direction. What I also do see is that on the factory floor, even factory managers start to put cameras everywhere to understand what's going on. And not all machine builders do like it because they control the machine and the output of the machine by that. So I think there will also be a merge between the traditional manufacturing machines and managing the production flow by the plant managers.
Okay, thank you. So autonomous system without embedded vision, just impossible. Good. What challenges do you see looking at embedded vision? So we have been having this discussion on embedded vision now for quite a few years, and the last part of the discussion is always about the future. So to tackle the futures, what hurdles do we need to overcome? What challenges do you see? Who would like to start?
So I think if I hear your roadmap, and if I look at the roadmap of other vendors, I think on the hardware side, from my personal point of view, it's laid out. So we're on a very good track. This was very different a few years ago, where it was very uncertain in which direction the roadmap really will develop. So I'm very happy that we are on a point now where we see constantly adding more performance on the hardware, constantly adding more usability on the stack level. My concern is more, and I briefly elaborated already a little bit on that, which is this training mode for AI models. If we would have the ability to do this, and I'm saying this in this way because I don't think this is a hardware-only problem. There are also software solutions to it in various ways. So if we would make a step forward in that direction, so we would gain more flexibility in the application. And this is something where customers are looking at on if they run an application in the longer run.
I would agree. I think a lot of challenges come along with the training data and controlling them, having the right training data available that you need, being able to also manage this typically huge amounts of data. This is certainly something where there is solutions that are emerging, but I don't see yet a consistency across that, and I know that many customers are suffering from it. So software, a consistent software landscape framework specifically around data training is something I have identified. One means to address it is simulation again, synthetic data. That's where also first frameworks are in the market. So we shall see how these are adopted.
Just a short one. I think it's also a big challenge for many to understand the system level. It needs to be deterministic. It needs to have a certain quality level so that you really design a system that works afterwards in the way you anticipate that to work. And that's a different story compared to the old days where the components and the hardware and everything was pretty much defined so that it's easy and not so failure effective or failure. It was easier to make failures. Now you really need to understand it on the system level, from the optics through the deterministic behavior. And I see that still as a big point.
And you're right. And the one thing I would like to emphasize is that also with the tendency to move from the factory floor to the outside world, to the real world, things become a lot more challenging because you can't control anymore the illumination conditions. You can't control necessarily humidity, temperature, all of that. But still, you expect your product to perform like you designed it in the lab. And there is a big gap between how it performs in the lab and how it performs in the real world. And that's definitely something that many people underestimate.
Yeah, and the last point I'll add to it, Anne, is in the context of challenges, I think Frederik made a great point on the accessibility of data upon which models are trained. I think we have a lot of work to do as an industry collectively to find a common point where industries can share data more freely, because proprietary data sets are important, but they also restrict how well a model can be tuned to just what you know and see for yourself. Combined data sets across industries can provide so much more insight. So I think there's a challenge to be overcome there that will help stimulate more growth and more development. The other point I'll make is that as all of us use more forms of compute and increase the deployment of more AI at the edge, we are increasing the power consumption challenge. And energy will continue to be a challenge as we look to see how do we enable the level of power required to support all of the deployment and implementations that we envision, even though we're continuing generation over generation to create more power efficient outcomes. We're still going to have to address some of the power challenges out over the next several years as well.
Definitely. Further questions from the audience? I see one here. Konstantin, I'm sorry.
Hey, probably a naive question, but have you guys had any discussions or experiences with ethics in physical AI and incorporating it in factories and medical? Do you guys have any thoughts or discussions on it?
Ethics, ethical, legal, societal questions when you deal with AI.
Ethics. In Europe we do have the AI Act. So this act actually explicitly describes for what purpose you have to do what if you use AI. So this is very explicit. So there's no way to use AI for scanning through applications of people and then sorting them out or in or so. So you have to be very precise on what you do with your AI application. At least this is Europe. So I would say that that act already gets a very good framework for an ethical system. This is, at least for a company like us, this is a guideline. I'm not saying this is complete, but it exists and we have to follow.
Another question here, please. So with regard to ethical and legal questions, EU, I think, is leading in AI. So there's a lot of rules and frameworks available, and people really have to stick to it. And also companies coming from outside of Europe, when they enter the European market, they have to comply with the EU AI Act. So
Is it some law?
it's like really. It's really written what you should do, and you have to make sure about security and so on. So it's really worth looking into it. And there's a lot of discussion going on, and some foreign companies, they think it was invented by the Europeans to to secure the European market. It's not true. So please.
I want to follow up on the question, similar direction. So AI is moving very fast, and then there's different approaches in Asia, maybe in North America, in Europe. We got the NDAA compliance, we got CRA, Cyber Resilience Act. We got all kind of security layers also on autonomous robots that maybe we have in Europe and we don't have in Asia. So I'm wondering both on the hardware and the software side, and how far you see this as necessary evil or also limiting and maybe even dangerous not to move as fast as others are doing because of regulation, standardization, anything like that.
That's a tough question.
I'll take part of it though, because I think implicit in the question is, what do you ensure that a robotic system is capable of doing? And then how can you ensure that it is compliant with regulations and or safety standards? And it's actually a really important question, because when we think about the technology underpinning what makes it work, there's the processing technology. I've talked enough about that today. However, we also ensure that within that there's a functional safety capability. Can you certify this system to be functionally safe? Then is it time deterministic, and can it exist in the real world, and can it support in environments that are, ruggedized and temperature demanding, etc. Right at that safety piece is critically important, where an autonomous device exists in a location where it's deployed with human beings, and ensuring that it can fail to a safe position in working. So that's something we focused on. That we'll do that regardless of whether a specific localization or region demands it from a regulatory perspective or not, because the truth of it is, it has to happen and has to be capable of deploying in that manner. And so we tend to, like the ethics question, take the most constraining case, most demanding case, and ensure we're meeting that. And that sets the bar by which then we want to ensure our technology or our solutions are enabling our customers to deliver to what it is they need to do. So it's almost looking at it from that perspective. What is the most extreme case you need to solve for, and solve that, then everything else will flow as a result. But whether there's regulation or not is less the issue. It's, can the technology provide the solution? And that's how we think about it.
Okay, thank you. And also looking at, for example, standardization, how standardization is done on a worldwide level. It always starts with a product. So it does not start with a research and what is possible. It always starts with what is there to go into the market. And then you look usually into the safety regulations. And so I guess moving ahead, there is more to come, not only from the legal side, but also from the standardization side. So, gentlemen, we have 2 more minutes. Should we wrap up? So when we meet here, maybe in 5 years, embedded vision. What's your vision? Embedded vision in 5 years. Frederik, let's start with you.
That's my vision. Well, I would say there is still an image sensor, there is still a lens, there is still a compute platform. I'm pretty sure about that. There is no quantum computing yet at large scale, so it's still classical silicon-based computing. But just like we actually opened here, I think the specific technologies we are seeing will be a lot more evolved than what we have today. And with that, the applications are even broader, and we will see embedded vision to be deployed at even larger scale.
In 5 years, I think we will have computational power directly attached to the CMOS sensor, which will help us do some great pre-processing.
Great outlook.
I think I'll just add, I'll say that 5 years ago, we would not have thought we would be doing what we're doing today. And 5 years ago, if you asked somebody what an LLM was, they'd probably have looked at you blankly. Now it's pretty standard. Even generative AI, people say, what's generative AI? And yet today they have multiple apps on their phone, all of them are generative AI. So if we roll it forward 5 years and we get a little bold and say, well, probably a couple of things will have happened. We'll have seen some hardware architectural evolutions, particularly in the area of memory, I expect, because memory bandwidth is a limiter for the level of AI model that we can support today. Size-wise, performance-wise, that bandwidth will get addressed through differing technologies. There are concepts of stacked memory or 3D memory. There are ways of resolving for that I think we'll see more mainstream by then. I think architecturally the compute will continue to evolve, providing for more performance in a heterogeneous manner in an increasingly power efficient envelope. I think that's a given. We like to pride ourselves on Moore's law. I think that's going to continue to enable that to happen. But I also think we'll have seen more embedded compute, as Olaf said, closer to the point of consumption. So what we think of today as multiple systems where you have peripherals that are doing sensor ingestion, like computer vision, but thermal or pressure or touch. I think we'll see more compute closer to those points that'll allow us to increasingly create more adaptive applications. So I think physical AI will be a reality in 5 years.
In 5 years.
And we'll talk more about what's coming beyond that.
Thank you. Henning, in 10 seconds.
In 10 seconds, I think what we will definitely see as industry is not always moving so fast. We will see the embedded vision in much more applications than we see today, especially in the industry or in the manufacturing, where it's not yet so present.
So, gentlemen, thank you, Henning, Olaf, Frederik, and Sean. That was the panel discussion on embedded vision 2026. And we saw that new hardware design and AI are really pushing embedded vision, and there's yet more to come. So thank you, and thank you all for coming and your interest.